I want you to practice this kind of problems. It's a very important type of problems. Another one. 3 charges, each of magnitude 3 nanocoulomb, are separated at the separate corners of a square of 5 centimeter. The 2 charges at the opposite corners are positive and the other charge is negative. Find the force exerted by these charges on a 4th charge Q4 equal to 3 nanocoulomb at the remaining corner. Now, what I would like you to do is, now stop the video now and see if you can picture, if you can draw a diagram of this. You have a square. You have 3 charges of 3 nanocoulomb are at the 3 corners of a square. Now, the 2 of those at the opposite corners are positive, and you need to find the force exerted by these 3 charges on a 4th charge or equal quantity placed at the 4th corner. Now, here is the diagram. I have Q1, can you see this? Q1 is 3 nanocoulomb. There is Q2, there is Q3, and there is Q4. We have said the 2 charges at the opposite corners are positive. So if Q1 is positive, then Q3 is positive, Q2 is negative. Alright, we need to find the force on Q4. Alright, let's first of all figure out the distances. We need to find the force on Q4 by Q1. That means you need to know the distance between them, R14. That is the side of the square, which is 5 centimeter, 0.05 meter. Then we need to find the force on Q4 by Q3. The distance between them is again 5 centimeter, 0.05 meter. R34. Now, you need the distance between charge Q2 and Q4. What is that distance? This is the diagonal of this right triangle. That means this R24 squared, the distance between charge Q2 and Q4 is what we call R24. The square of this distance is square of this plus the square of this, 0.05 squared plus 0.05 squared. Can you do that and tell me if this is true? R24 squared is 0.005 meter. So now we have all 3 distances. What are the forces we need to find? We need to find F41, force on Q4 by Q1. We need to find F43, force on Q4 by Q3. And we need to find F42, force on Q4 by Q2. And then find the vector sum of these forces. Alright, let's get going. F41, the force on charge 4 by charge 1 is K, Q1, Q4, they are both the same, divided by R14 squared, right? And that is 3.24 times 10 to the negative 5 Newton I. Well, if you calculate this quantity on the calculator, you will get this number. How do I know this is a positive X force? Q1 is a positive charge. Q4 is a positive charge. Therefore, the force on Q4 by Q1 will be a repulsive force. It will be directed away from Q4. There you are. It's directed away from Q1. So this is force F41, which is equal to this 3.24 times 10 to the negative 5 Newton I. Similarly, let's find F43. F43 equal to K Q3, that is 3 times 10 to the negative 9. Remember 3 nanocoulomb, 3 times 10 to the negative 9 times, this is also 3 nanocoulomb, 3 times 10 to the negative 9 over 0.05 squared. Now, sometimes some part on the screen may be cut off. That's why I want you to keep the PowerPoint printed in front of you when you watch these lectures. Now, what does the magnitude of this give you? The same as this. That will be negative 3.24 times 10 to the negative 5 J. Well, 3.24 times 10 to the negative 5 is the magnitude of this. How do I know it is a negative Y force? Because Q3 is positive, Q4 also is positive. The force on Q4 by Q3 is a repulsive force. That means it will be directed away from Q3 in the negative Y direction. That is how I get the direction. I hope you understand that. So F43 is negative 3.24 times 10 to the negative 5 Newton J. Let's now find F42. Can you do that on your own? Well, F42 will be K times Q2 is 3 times 10 to the negative 9. We are not using that negative. We use the absolute value. 3 nanocoulomb times 3 nanocoulomb. We converted that to coulombs. Divided by R24 squared is 0.005. And that gives you 1.62 times 10 to the negative 5 Newton. Now you can see I haven't put I or J there. Why? Because I don't know yet. What is the direction of this force? Now, Q2 is a negative charge. Q4 is a positive charge. So Q4 will be attracted by Q2 because Q2 is a negative charge. So this force will be directed away from Q4 and makes an angle with the x-axis. It will be directed from Q4 to Q3 because it is an attractive force. A negative charge attracts a positive charge. So F42 will be directed from Q4 to Q2. And what is this angle? That will be very simple to find. Why? This is a right angle 90 degrees and this right angle is bisected here. So this will be 45 degrees. So this angle, total angle will be 90 plus 45, 135 degrees. Okay, now we need to write this in the component form. Can you help me write that in the component form? This is the magnitude 1.62 times 10 to the negative 5 and 135 degrees is the angle. Let's do that. The angle is 135 degrees. Alright, let's write that in the component form. F42 written in the component form will be the magnitude times cos 135 degrees I plus the magnitude times sine 135 degrees. The magnitude is 1.62 times 10 to the negative 5 times cos 135 degrees I plus 1.62 times 10 to the negative 5 sine 135 degrees J. Alright, let's work it out. That will be negative 1.15 times 10 to the 5 I. So the x component is a negative force and the y component is plus 1.15 times 10 to the negative 5J. That is a positive component. So we already calculated this. F41, I'm writing that again. F41 is this force, which is 3.24 times 10 to the negative 5 Newton I. And F43 is this. And now you have F41, F43, F42. The vector sum of these forces are simply the sum of these three. Can you add this, this, and this? What you should do is add the x components. That means the ones that contains the I, and then add the ones that contains j. So F41 plus F42 plus F43 equal to, I want you to watch the way I write it. Now the I component, I write it like this. 3.24 times 10 to the negative 5, that is positive, minus 1.15 times 10 to the negative 5 I. You see that? This is the total x component. Now plus. And now find the total y component. What will that be? This is positive y, this is negative y. That will be 1.15 times 10 to the negative 5 minus 3.24 times 10 to the negative 5j. So the total x component plus the total y component. Alright, can you use your calculator to work this out? That gives me 2.09 times 10 to the negative 5i minus 2.09 times 10 to the negative 5j. This is the component form of the total force. Now, you need to bring it to the magnitude angle form. We will do that in the next slide. So the net force in the component form is this. How do we represent that in the magnitude angle form? Well, this is the net force is made up of an x component. This is the x component, 2.09 times 10 to the negative 5. And then its y component is negative 2.09 times 10 to the negative 5. That will be this vector. 2.09 times 10 to the negative 5 is a negative y. And we want to find the sum of the two. The magnitude of the force is, well, if you got to complete that triangle, this is the magnitude. The magnitude will be square root of this squared plus this squared. So F equal to square root of 2.09 times 10 to the negative 5 squared, that is x squared, plus 2.09 times 10 to the negative 5, that is y squared. And that will be 2.96 times 10 to the negative 5 Newton. And that is this vector. That is the net force on Q4 by all the other three forces. Alright, what is the angle it makes with the x-axis? Theta, if this is the angle theta, then tan theta will be y divided by x. This is my y and this is my x. So theta will be tan inverse of 2.09 tan inverse of, you can see my y is negative and the x is positive. And that means you get negative 45 degrees. Is that right? Because this is a fourth quadrant angle. So we got the magnitude and the direction. And this is a pretty good way to solve problems like this. You see, all the skills we learned in adding vectors in Physics 1 is actually used here. I had told you during Physics 1 that we will use this in Physics 2. So if you have problems with this, you need to go back to Physics 1 and review some of this. Or just get back to me, I can do more explanations if you need more explanations.